All right, on this one, we're going to use law of conservation of energy to determine what the potential energy, the kinetic energy, and the velocity is at different times on this specific roller coaster. Now, a couple things. This chart is not on your page, so you're going to want to definitely go ahead and draw that. So go ahead and pause that here. We don't have enough information about B. It looks a little bit lower than D. So I'm not going to bother adding it to my list. So don't worry, I've purposely ignored it. I've given you some heights, just made up some heights for A, C, and D. And then I gave you a mass for that object. I do want you to also operate under the assumption that at point A, your velocity is 0, meaning all of the energy is in the form of potential energy. All right, so let's go ahead and tackle these one at a time. The first one is point A. So at point A, of course, we're looking at our potential being the gravitational potential energy, plus our kinetic energy is going to equal our total mechanical energy. We don't know how much total mechanical energy we have yet, but we do know that at the very, very top of A, it's not moving. So I can get rid of my kinetic energy. Well, this gives me a wonderful equation to go ahead and find my total mechanical energy. So mgh is going to equal me, and I'm just going to put T for total. It's assumed that it's a total. All right, my mass is 250 kilograms. And gravity, we're going to use 10 meters per second squared. And then my height on that one I said was 80 meters. So 80 meters in height. So that gives us a total value of 200,000 joules. Okay, now a joule is the same as a Newton meter. It's just when we're speaking of energy, we use the unit of joule. It's a kilogram meter squared per second squared if you're looking at the breakdown. All right, so now we know our total mechanical energy, which is 200,000 joules. I do know that my potential energy here is 200,000 joules. Let me increase that a little bit. My kinetic energy is 0, which means my velocity is also 0. Okay, so let's look at point C. So at point C, I'm going to change my my pen to red for this one. So at point C, I have 0 meters. Okay, so at C, PE gravitational plus kinetic energy is equal to mechanical energy. Because my height is 0, my potential gravitational energy is 0, which means my kinetic energy is equal to my total mechanical energy. Well, I already know that value, so I'm going to go ahead and put that up here. So it's 200,000 joules, and I have 0 potential energy there. But I still have to figure out my velocity. So 1/2 mv squared. And I'm just going to set it equal to kinetic energy. We know that these are actually the same at this point, just for this particular one. To get our velocity, I have to multiply both sides by 2. And that knocks this out. And then I divide by m. And then I got to take the square root to get rid of the square. So V, get the, let's see here. Erase this here. V is equal to the square root of 2 times my kinetic energy over the mass, which is square root of 2 times 200,000, because all my energy is in the form of kinetic energy, and 250 kilograms. Okay, so my velocity for this, once I take the square root of everything, is a whopping 40 meters per second. All right. So I'm going to stick that up in our chart. So 40 meters per second. Now what I do know is that's when all of my energy is in kinetic energy, so KE max. So that should be my maximum velocity as well. of this particular one. Well, now we've got to cover D, and I'll do D in black pen. And so D is 50 meters above, so it has a little bit of potential energy and it's got a little bit of kinetic energy because it's moving. So the way we handle that one is we say my potential energy plus my kinetic energy is equal to my total mechanical energy. Now we have the ability to figure out what my potential energy is, so I could rearrange this equation to say my total mechanical energy minus my potential energy is equal to my kinetic energy. So I'm just subtracting PE from both sides. Well, I've got 200,000 joules minus, let's see what our PE is. Our PE is going to be 250 kilograms times 10 meters per second squared times 50 meters. So when I put all that together, I end up with 125,000. So my kinetic energy is equal to 200 minus 125 is 75,000 joules. So I can go up here on my chart. This is 125,000 joules. This is 75,000 joules. So notice that these two things add up to equal my total mechanical energy, right? I can't create more energy than I have. And the only thing left to do is to find my velocity, and I can just use this equation instead of rebuilding it. So my kinetic energy is 75,000, so 2 times 75,000 joules over my mass of 250 kilograms is going to give me a velocity of 24.49 meters per second. So up here, 24.49 meters per second, which makes sense because it's less than our max, which was 40. Okay, so this, I'll pull it back there for you so you can see the whole thing. This is the way that we handle our max potential energy, our max kinetic energy, and using one of those two to figure out what my total mechanical energy is. And then part D, which actually has me manipulating and including both my mechanical and my potential. So those are the types of questions that you're going to have on your quiz. And hopefully there won't be a snow day, and we will see you guys back at school.